Good morning and welcome to our lesson today. This is lesson 7.2, the division property of exponents. The division properties of exponents. I'm going to teach this lesson over 2 days. So let's go ahead and jump in and get started today. The first rule I'd like for us to look at today, which I have highlighted in your notes, is the quotient of powers. The quotient of powers says this: a to the m power divided by a to the n power equals a to the m minus n. Now you remember yesterday when we talked about product rules, we talked about a to the m times a to the n. So if you're multiplying and the bases are the same, you add the exponents. If you're dividing and the bases are the same, we subtract the exponents. So let's start off really nice and easy because they jumped right into some big examples there. So I want to take it in baby steps for us this morning. So let's do a couple of simple examples using the quotient of power rules, which says a to the m power divided by a to the n power equals a to the m minus n power. So if I gave you x to the 10th over x to the 6th, we are going to say that is equal to x to the 10 minus 6 or x to the 4th power. Now let me prove to you why this rule works. So just stay with me here for a second and let me show you. So this is a very visual representation of why this rule works. And for some people, this is extremely helpful. Takes a little bit more time, but sometimes if you get stuck, it really makes the difference. Okay, so I have 10 x's on top. That represents x to the 10th power. I have 6 x's in my denominator, which represents x to the 6th power. And now, remember, when we divide, anything that's in the numerator and denominator can cancel out. Anything divided by itself equals 1. And I'm left with x times x times x times x, or x to the 4th power. The answer is always the same. Are you with me? Okay, so let's try a couple. So this is example. Let's do that as 1. And we're going to get you involved here in a minute as well. So let's go m to the 6th over m to the 4th. I'm actually doing a lot of them that are in your notes. M to the 6th over m to the 4th. When you do number 4, don't just leave it as something like 5 to something power. Go ahead and tell me, what does 5 to that power actually equal? So please use your calculator. Come on, guys. No, you can use the rule. I'm just showing you both ways. All right, so let's look at our second example here, guys, and let's see what we've got. M to the 6th over m to the 4th power. Our rule says a to the m divided by a to the n is a to the m minus n. So this would become m to the 6 minus 4, or what did y'all get for an answer? M to the 2nd power. Good job. Our next one is a cubed over a squared, which would be a to the 3 minus 2, which is a to the 1st power, or just a. And our last one, 5 to the 5th over 5 to the 2nd, is 5 to the third power, and we all know that 5 to the third power is 125. Are there any questions on those first few? All right, so now let's make our life interesting and let's just pick it up a notch. Let's do something like this. This example is in your notes. This is actually example 1, so I'm going to be right here right now. I'm going to be on this example, but I'd like to work it for you because I want to show you something that I think will be extremely helpful. Okay, so this is a to the 4th, b to the 7th, over ab squared. And I kind of wrote mine a little far apart because I want to show you what I do, which I think might help some of you. So I actually just go ahead and put a dotted line down there because that helps my mind compartmentalize. So I keep the a's together, I keep the b's together. And then this is what I do. Remember, if there's no exponent, there's a 1. So I go a to the 4 minus 1 times b to the 7 minus 2, which would give me what? 4 minus 1 is, and 7 minus 2 is, which gives me a cubed b to the 5th as my answer. Now let me show that to you visually. A visual representation of the same problem is sometimes extremely helpful. Okay, and now we're ready to go ahead and to cancel out. You can cancel 1a and 1a, 2b's and 2b's, which leaves me a times a times a, which is a cubed, and 1, 2, 3, 4, 5, b to the 5th power. So no matter which way y'all decide to do it, you get exactly the same answer. Exactly the same answer. Does anybody have a question? Let's try another one. Let's let you guys try this one. X to the 4th, y to the 7th, z to the 10th, all over x, y to the 5th, z to the 3rd. And the directions will say simplify. So I'm gonna say to you, if you want, you can use that little trick that I gave you if this is helpful. If you want, you can compartmentalize to keep the x's, the y's, and the z's separate. You have a question? Okay. Okay, what'd you get for an answer, John?
I got x to the x cubed, y squared, and z to the 7th power.
Okay, let me just fix something. I don't know why I made the y in mine. I made it a b, which really don't know where b came from. So let me fix it before I display the answer here. X cubed, y squared, z to the 7th. Is that what you got? That's what I got. Does anybody have a question? Okay, let's go ahead and look at our second rule today. Our second rule is called the power of a quotient rule. The power of a quotient rule says this: for any numbers a and b, where b does not equal 0, a over b to the m power equals a to the m over b to the m. So what that means is everything that's in parentheses has to be taken to the power of m. So let's spend some time on that rule. This is called a power of a quotient. which is a over b to the m power equals a to the m over b to the m. So let's go nice and easy here. Let's go x squared over y to the third power. So the numerator would become x to the 2 times 3, and the denominator would become y to the third power, or your final answer here would be x to the 6th over y to the third. Are you with me? Hello? Okay. All right, let's try another one. Let's try x plus z. So I want you to rewrite the numerator. So the numerator is going to become x to the 3 times 3, y to the 2 times 3, and z to the 2 times 3. What's your denominator going to become? X to the third, y to the z to the... Okay, so now I want you to simplify your numerator, and then you need to reduce the entire fraction. Anybody have an answer they'd like to share? Right here in the front. Thank you. Okay, you have to reduce. Oh, you have to reduce that. Anybody else? What did you get? X to the 6th, y to the... That's what I got also. So let's show you why. Everybody take a look, and let's see what we have. It's okay. Come on, stay with me. Do you understand how we got x to the 3 times 3 gives me x to the 9th? Y to the 2 times 3 gives me y to the 6th. Z to the 2 times 3 gives me z to the 6th. All over x cubed, y cubed, z cubed. Now, what you have to do is you have to take it one step further. And so now what you're doing is just like you did before, like we started off with, nice and easy, using the exponent rules. X to the 9th over x to the 3 is 9 minus 3, or x to the 6th. Y to the 6th over y cubed is y to the 6 minus 3, or y to the 3rd. Z to the 6th over z cubed is z to the 6 minus 3, or z cubed. Are you with me? Okay. So why don't I'm gonna end there for today. No, I'm gonna do one more, and then we'll end. Let's do what is example 2 in your notes, which is 2a cubed b to the 5th over 3b squared to the 3rd power. Okay? So let's take it nice and easy. Let's rewrite the numerator first. So this is going to be 2a cubed b to the 5th, and everything there is going to the power of 3. I'm exaggerating this. I do not want you to miss out on what's happening. Now I'm going to take each part of the numerator to the 3rd power. So this is 2 cubed, a to the 3 times 3, and b to the 5 times 3. Does anybody have a question? Okay, so this becomes 8a to the 9th, b to the 15th. Now let's take care of the denominator. That becomes 3 cubed, this is a 3 here, 3 cubed b to the 2 times 3, which would become 9b to the 6th power. Yes? Are you with me? Let's see, we did something wrong. 3 to the 3rd power is not 9. 3 to the 3rd power is 27, and I knew that, so let's fix it real quickly. And that's a good, I'm kind of glad that I made that mistake because we do that all the time. We multiply 3 times 3, and 3 to the 3rd power is 27. So this should be 8 to the 9th, b to the 15th over 27b to the 6th power. Are you with me? Yes? Let's double check it, make sure we didn't mess up. 2 cubed is 8, is that correct? A to the 3 times 3 is a to the 9th, b to the 5 times 3 is b to the 15th. 3 cubed is 27, b to the 2 times 3 is b to the 6th. Okay, now you're ready to reduce. Do you see anything that reduces? The b's. So this becomes 8a to the 9th, b to the 15 minus 6, all over 27, or your final answer is 8a to the 9th, b to the 9th over 27. Questions? Thank you for listening today.